Hello, and welcome to the My Old Car video log, where I document how I maintain, repair, and occasionally make upgrades to my 1974 Chevrolet Monte Carlo that's been my daily driver since 1984. With dedication and tenacity, you too can make your first car your forever car and drive it forever. So I had this clock out in the garage in a box in the garage for a number of years. I'm finally getting around to checking it out to see if it'll work. Before I do that, before I even open it up, I'm going to do a continuity test on this thing. So let's break out with the continuity meter. Alrighty, come on. Yep. Okie dokie. Now let's see. Well, that's not a good sign. Bring in another one to give you a comparison as to how it's supposed to look. So here goes one that I repaired not that long ago. And let's see what happens with the continuity meter. Once again, let's check this one here. Nothing's happening. Continuity meter itself, yeah, it's registering. Now let's check this one. We have continuity. Here we don't. Here we have continuity. Well, there's something up with this. Let's go and see about opening it up, taking it apart to figure out what's going on. I'm going to predict that what's most likely up with this clock is that the coil inside the solenoid coils are probably fried. That's what usually happens with these. Let's go get ready to open it, check it out. Okay, so the steps in opening this thing up involve removing the hands off the face. Then if you look closely, you'll see how the face has these little tabs that need to be bent back, right there and right there. There's three of them. The reason why you need to take these tabs off is you see how this piece of the case is bent over. Well, it's bent over here, and let's see if we can, yeah, we can see it right there, right in there, and there should be another spot, yeah, right here. And so the only way to access these is to pull that off. Now fortunately, these hands, they just come straight off, so you have to be cautious about this and careful, but they do pull, and just got to be a little delicate with them. There we go. And they do come right off. Now you can see this is just a simple friction fit here, so this will just pop right off. And then the last one, again, this is a simple friction fit. There. There we go. You can see, you know, they're not damaged. You just have to be patient with these things. So we'll set those aside. Now comes the next delicate part, which is to remove this face. Yeah, figures. I'm going to get an X-Acto knife. I want to have a nice, clean, small, tight edge before I go ahead and start prying that thing apart. Okay, let's see here. I'm just using this to get me started. Create a little bit of a gap. Yeah, seeing how this this face is aluminum, you really want to be gentle with this. You don't want to have this thing get so mangled to where it's not going to go back together, or it's going to break. So yeah, be real careful with this. Alrighty, this should come off. Come on. There we go. Thought I had that done. And there we are. Now you can see these areas that are bent over. And it's not that difficult to actually bend them back. I mean, this is steel, so you don't have to be as gentle as you were with the face, but you are still going to be needing something that's kind of stout in order to get these things bent open. I don't know if this is going to be stout enough. Probably not. Let's try this. And again, you don't want to get overly enthusiastic with this. Just enough to where this will loosen up and allow this cover to come off. Well, let's see if that'll work. See if we can give this the old college try. Ah, yes, it will. Here we go. Now you're ready for the guts. Let's see how this looks on the inside. You can see you're gonna find resistance because of this, resistance in terms of pulling it out. There we go. Hey, look at that. We are actually in luck. These look really good. In fact, these look like they're not damaged in any way. And point out some things here. Okay, these are the coils for the solenoid. Let me get into a better angle here. There we go. Alrighty. Now these are the coils for the solenoid. This is one wire that goes up to one end of the solenoid, and the other end goes to this, it's hard to see, but right here, let's see if we can see that. Right inside here is the other end. Because there's a terminal on that end. And that terminal, which you might be able to, you know what, let me go get a flashlight to actually really light this up. Alrighty, let's see. I'll be able to see this now. Okay, there you can see the contact where the other end of the solenoid wire should be connected to. Should be able to light it from here too. Let's see. There, that's lit pretty well. That's the other end of this. The end that we're concerned with is with regards to when this thing winds, because this here is the winding spring. And this is, you know what? This feels like it hasn't been assembled properly. Oh wow! Actually, it feels like the spring on this might not want to work. Oh wait, it seems to be working now. It looks like it wants to work. But for whatever reason, this thing, it doesn't look like it's set up right. Or it's missing. There's something up with this. I'm going to take this thing more apart in order to actually effect some kind of a repair. But this, because the coils look like they're okay, it should be fine. I'll tell you what I'm going to do. I'm going to check the yeah, totally. Yeah, I'm going to check the continuity on this and see what it tells me. Alrighty, let's see. Well, what do you know? And just to be certain, yep, no part of that is grounded. Oh yes, the repair on this should be pretty straightforward. So, now that I get it apart, I'm actually going to sit down and repair this thing. That way I'll have yet another clock that I can put into service. So let me set this one aside. Go ahead and set this one aside because, as I said, what luck. When it's clean like this, you're doing great. Let me go ahead and set this aside. And I'll bring in a clock that is a lot less fortunate. So I think this one might be worse. Let me see. Ah, yeah, you kind of see just how fried this is. Under normal light, I mean, this has been totally cooked. So the only way to fix this is to completely rewind, strip off all the wire, get some insulated or varnished wire, winding wire, rewind these, and solder everything back together, and then it should work. What usually causes this sort of a problem, there are different things that cause this kind of a problem, and I'll detail it in the description as opposed to wasting a bunch of your time right now. In any case, so this is the clock that's a little bit more cooked. As you can see, the the windings on the solenoids are it's obvious. So in diagnosing, one of the things that I've done is actually, let me explain a little bit about the anatomy of these clocks. This here is the winding spring. You may be able to see, it's hard to see, maybe from this angle. In this angle, there are, you can see, man, it's really hard to see from here. And anyway, but inside here, when you look down this hole, you can see the two contacts. One contact goes to the coil, the other contact goes to ground, or in other words, like these are plus and minus, the positive and negative or ground. So when these come together, of course, this solenoid energizes. When the solenoid energizes, there's a lever right here, this lever, and it moves. Well, this one's fried, so it won't move. But what it would do is it would pivot, and when it pivots, it kicks this. This is the winder. So it would kick this out. In fact, here you can actually see the other contact right there. Now, when this thing kicks and it winds the spring, the clock should run if everything else is all right. And in this case, you can see the clock starts running. This is a really good sign. This lets me know that all I would need to do would be to replace this the solenoid, and should be able to get it to work. So on that note, you can see the little flywheel thingy spinning around. So to replace this, you have to undo these three screws. This one, and that one. And when you do this, this winder assembly is going to want to come apart. So try to keep that from happening, but if it does come apart, there's no need to panic. I'll show you. Alrighty, now comes a moment of truth here. Let's see if we can get this to not come apart. See, and there's nothing much to it. This is it. It's all there is. So we'll set this aside, and then let's assume you get another one. You have another one ready. You put it right back on. I'm going to reuse this one just for illustrative purposes, but let's say you have one ready. You just go ahead and line up line up these two with that, and of course the axis, the axle for the winder has to go into its own special hole. Now this is a legit clock, so nothing here can be forced. If you force something together on a clock, then it's not going to work. I guarantee it. So this is now back together, and you can see the flywheel is even still turning, or it's oscillating. But let's say you put this thing apart, and this thing you let go, and it goes whee. Be delicate, but let's say, oh gosh, it just came apart. Heck, you can even go so far as to remove this completely. And this is the spring that, the end of the spring that goes into there. So if this comes apart, you're thinking, oh great, I'm hosed. No, you're not. Now, one of the things to note is the condition of this terminal here. Right there, that's the terminal that makes contact, just like the contact points in your ignition if you still have old-fashioned style ignition. So just note those. If they need to be cleaned, get some really fine emery cloth and just touch it up. No big deal. So putting this thing back together, as again, no big deal. What we're going to do is, and this is, I may not be able to do this in full view of the camera, but I'm still going to give it the old college try. The only thing that's really critical is to keep this in between. Let's see, how does this go on here again? Yeah, so keep this in between here and there, because otherwise it'll bind. So put this together. What I found works for me is I'll slip this on first before I put this back into its axis. There we go. And then I tilt this outward and start winding, all the while making sure that this long spring stays in its channel and gets coiled up correctly. There we go. So yeah, there's a little bit of finessing with, and now it's time to start winding. And what you want to do is gently keep winding until it stops wanting to wind. Once you reach that max, then bring it back just to about here, to about right there. Put it together, grab your solenoid assembly, and then reassemble. There we go. Get this back into get the axis back into where it belongs. And this is the only real difficult part, is getting this thing all lined up. But it's nothing that the average person can't do. Anyone who's reasonably mechanically inclined can do this. And there we are. I just need to put the screws back on. You can see the flywheel. Oh, it just stopped. Oh, it's because my finger got in the way of the second hand. So anyway, we'll get this thing all together. Oops. This sits in, there's a little tab right here that goes into this little hole right there. So sits in there like that. And then this screw helps this thing become the ground. Come on now. There we go. And just tighten these down. Again, bear in mind this is a clock. The solenoid sits on a plastic frame, so you just want these to be, I don't know, it's hard to describe this. You don't want them to be torqued, but you don't want them to be simply snug, just a hair over snugged, if that makes any sense. Now let's say I went through and I actually replaced these and went through, cleaned it. When I get ready to oil it, I use a legit clock or watch oil. I actually prefer to use a watch oil rather than a clock oil because this is a smaller mechanism than like a large grandfather type clock. So, you know, I just use a synthetic lubricant with a needle tip, because you really don't need much of this at all. Just take it, and where this thing pivots, you put just a dab on this side, a dab on that side, and then also where there's a little oscillating arm, you put a dab, literally just touch it there, and then you touch it on the other side, and that's what I've usually done. And I find that my clock runs for 10, 12, 15 years, and it needs something. So there you go. So there you have it. There goes a quick, disassembly and diagnosis of what's up with the clock. As I said, most of the time, these coils are fried. To find one like we saw here just now, this is like this is one of those miraculous sort of discoveries, that this thing, it just simply has something going on with this winder right here. I don't know why it's doing what it's doing, but I am going to be effecting a repair on this, so that way this will be ready to go. I hope this has been helpful and useful. So thanks for watching. If you enjoyed the video and found it useful, please be sure to click the like button. Now if you'll excuse me, I think it's time for a drive.